Welcome to the presentation of Basics of Optical Fiber Communication. Learning outcome. At the end of this session, student will be able to explain the propagation of light in different types of optical fibers. I am going to cover basic definitions, light propagation, then what are the different types of optical fibers. So in basic definitions, I am going to cover the refractive index of medium, then what do you mean by numerical aperture and acceptance angle of the optical fiber, and what are these meridional rays and skew rays. So let us look at the refractive index of the medium. Refractive index of the medium is defined as the ratio of velocity of light in vacuum to the velocity of light in the medium. So as it is the ratio of velocities, it is unitless, that is it doesn't have any unit. The refractive index of air or the vacuum is unity or 1. Now what are these meridional rays and skew rays? So these rays have been defined with respect to their propagation through the fiber axis. So the meridional rays are the rays which always pass through the axis of the fiber, giving high optical intensity at the center of the core of the fiber, whereas the skew rays are the rays that never intersect the axis of the fiber, giving low optical intensity at the center and high intensity towards the rim of the fiber. Now what is numerical aperture? So basically numerical aperture says the capacity of the optical fiber to collect light. So that is, the light collecting capability of the optical fiber is nothing but numerical aperture, and it is unitless. So acceptance angle or the maximum angle, it is the angle at which light ray may enter the optical fiber in order to be propagated, or you can say the angle at which the light ray enters the optical fiber and it is totally internally reflected. So before going to the next slide, recall the definitions of reflection of light and refraction of light. So that is, when a ray of light travels in a medium, hits a surface and reflects back in the same medium, so that is nothing but reflection of light. Whereas refraction of light says, if the ray of light hits the surface and travels in another medium, so that is the refraction of light. So keeping these two definitions in mind, let us look at the propagation of light in optical fibers. So basically the light propagation in optical fibers, it depends upon the type of material that will be used. So the type of material or the medium, so they may be different types. That is, first one, it may be of transparent, that is it may be clear material. So if at all if the material is clear, then it is going to transmit the light, whereas if the material is translucent, that is if we can see through the material, so it scatters the light. But whereas if the material is opaque, that is if we cannot see through the medium, then the material absorbs and reflects the light. However, the light travels more slowly in optically dense medium than in one that is less dense, and the refractive index gives a measure of this effect. Now let us look at the optical fiber structure. The optical fiber basically consists of two concentric cylinders. The inside solid cylinder, that is called as the core, whereas the outside shell protecting core is called as the cladding. So this structure, it is similar to the plastic fiber as well as the glass fiber. So usually cladding will act as the protecting shell to the core of the optical fiber. So the optical fiber is basically a dielectric waveguide, and here the light travels like an electromagnetic wave, and if the light radiation is not confined inside the fiber but also extends outside the fiber, for the light to propagate inside the fiber through total internal reflections at the core cladding interface, then the condition is that the refractive index of core should be greater than the refractive index of the cladding. So if at all, if N1 is greater than N2, then total internal reflections occur inside the optical fiber, and then the light travels in the optical fiber. Now let us look at the different types of optical fibers. So basically there are two types of optical fibers. First one, step index fiber, and second one, the graded index fiber. So these fibers have been classified on the basis of refractive indices. So here in the step index fiber, let us look at the refractive index profile. So this refractive index profile, it somewhat looks like a pulse or step, and this kind of fiber, it is called as step index fiber. So this structure is useful for analyzing the propagation of light inside an optical fiber. Generally, it is not used in practice because the data transfer rate in this fiber, it is very less. Next, the graded index fiber. So the refractive index profile that you can see it on the slide. Since the graded index fibers, so we can grade the refractive index. It means the user who is going to use these types of fibers, he can predefine the refractive indices, that is the refractive index of core as well as the refractive index of the cladding can be completely graded or can be completely governed by the user. So that is what these types of fibers are also called as graded index fibers. So the assignment given to the student is explain the propagation of light in different types of optical fibers. So the textbooks I have referred are Optical Fiber Communication Principles and Practice by John Senior, 3rd edition. So Tata McGraw-Hill is the publisher, and second textbook, that is Optical Fiber Communication by Kaiser. So again Tata McGraw-Hill is the publisher. So special thanks to Walchand Institute of Technology Solapur and IDP in Education Technology IIT Bombay for providing this opportunity. Thank you.